Hey everyone, this is Mark, and in this video, we're going to be talking about Java loops and method loops, and use those expressions to modify a picture object and do something cool with it. So the first part is getting the picture object. First line right here is getting the media path or the picture that we're gonna use for a program. You can use a pick file method from the file chooser class if you want, so we can have different picture objects every time we run the code. But for simplicity's sake, we're just gonna stick to the church.jpg. And for the second line is creating the picture file, the picture object, passing in the file path. And then the third line is creating a copy of the picture object that we just created. Instead of passing in the file path, we just pass in the picture object itself. That way, the picture class can create a copy of it. And then fourth line is picture.show is just showing the original picture object that we just created. And then we're going to create a variable and set it to null as a preparation for the loop that we're going to create in just a bit. And then get the width and height of the picture and store it into a variable, which we use the get width and get height method from the picture object or class. And then get half of the picture width for the filter, which this is going to be useful later when we execute the loop. And then the nested loop. So we have here two for loops, one for the y-axis and one for the x-axis. This is useful if we want to access a specific pixel location of a picture object and want to apply or modify those pictures in one go using a for loop. So for the outer loop, we're gonna be looping over the y-axis or the picture height, and then creating a condition that continues the loop until it reaches the picture's height -1. We use -1 because pixels doesn't start with 1; it actually starts with 0. So it's only fair that we reduce it by 1, since the picture height gives you the actual height of the picture, and it starts with 1. And then the third part is for incrementing, or this is making sure that every time that we loop, that the y or the y-axis is incrementing by 1, so we can move forward with modifying our pixel object. And then for the inner loop is the x-axis loop. This is I said the x-axis for half of the width -1. I'm going to demonstrate why I did it. I did this at a later time. So to summarize everything, we're going to finish looping over the x-axis before we can move on to the y-axis. In order for us to better picture of what this code does, I prepared an illustration of a sort of how a 2D pixel works. So for the first loop, we loop over the y-axis, which is the height of the picture object. And then inside of the y-axis loop is the x-axis. So every iteration or every y coordinate, we need to finish looping the x-axis in order to move forward with the y-axis. So for example, the first iteration will be this first pixel right here, and then it's going to finish the y-axis first. Then once it's all done, it's going to move on to the second y coordinate, and so on until we finally finish the loop. So to run our code, to test it out, so this is the result of our program so far. This is the original picture, and this is the modified picture, or the copy of the picture object. As you can see, we have a slanting effect right here that darkens every pixel inside of it. I forgot to mention that we also have this half width and reduce it by 2 every time you finish the y-axis. That effect creates this slanting pixel modification right here. Since we start at the center of the pixel, or the center of the picture width, it's going to start at the center, and then each iteration, the center will shift 2 pixels every iteration. And then if you want to see how how that for loop converts into a while loop, I also prepared this snippet of code right here. Now this while loop right here is almost exactly the same thing as the first method loop that we have over here. The only difference is that it is a while loop, and with a few tweaks I did for a slightly different effect, but almost exactly the same thing. We can also mess with the while loop, but personally, it is much more complicated than having a nested for loop, because we have to remember to initialize a variable outside of the loop, and inside the loop, we need to remember to increment that. To increment the variable outside of the loop of the while loop, it's not very intuitive, especially for beginners. So personally, I like to use for loop for a nested loop. And the other changes that I made is, instead of having the x-axis be set initially as half of the picture object, I set it as picture width minus half of the width. This is gonna make sense once I run the code. So let's do that right now. But first, I'm gonna comment this out so it doesn't interfere. Instead of having the black pixels at the top left, we have it at the bottom right in a slanting fashion. This code right here is responsible for that. So every time we loop over the y-axis, the x-axis will be initialized with picture width minus the half width. And remember that we have at every time the x-axis loop finish, we reduce the half width by 2. So every time the y-axis is going to execute, it's going to assess how much width we're going to have in order for the x-axis to work on the black pixels. And then finally, I've prepared here a snippet of code that is more complete than the first two nested loops that we have over here. I'm just going to comment this out with some additional features. One being is I've added a spacing between each of the x iterations, or each time the x-axis is going to loop. Instead of having the increment of 1 or decrement of 1, I'm going to set the spacing or the incrementation or decrementation to 2. So by that way, we're going to have a gap between each of those iterations. We're going to see that in just a bit when we run the code. And then for the outer loop, it's still the same. The y-axis is going to be looping from top to bottom. And then the for inside loop is going to loop for each of the section of the picture object. The 4 corners that we have, the upper left, the upper right, the lower left, the lower right. And then it's going to have the same filter with the black pixels, if you can remember, the slanting effect in each of the corners. So to test our code, see if it's working, and then this is the result of this nested for loop right here. This is the original picture, and this is the modified picture. In each corner, it has a sort of a diagonal black pixel modification on each corners, which is kind of cool. If we want to tweak it a little bit, just make the spacing, example set it to 5, save, compile. And this is the result of having this spacing of 5. I don't know if you can see in the video, but it's much more spaced out than having a spacing of 2. It's even more lighter than before. It's kind of nice to have this feature right here. It gives you more flexibility with having the filter. And that's it for this video. I hope you like it, and good luck.